Hello. First, let me introduce myself. Myself Shubhashish, and I am a faculty of mathematics. I have been teaching mathematics for the last 15 years. Today, I shall discuss a very important topic of mathematics, and the name of the topic is domain and range of a function. Before I start the topic, domain and range of a function, I want to suggest you that first you go through the properties of function. Once you will go through the properties of function, it will be very easy for you to understand the topic. Okay, before I start the chapter, let me tell you, whenever we shall find the domain and range of a function, actually what we have to do. See, suppose if we take a function fx, and fx means it is y. Whenever we shall calculate the domain or range of this function, we are going to find the domain means we shall find the interval of x. Domain means we shall find the interval of x. We shall find interval of x. And how we can find? That is the question. We can find this interval such that y is defined, such that y is defined. And whenever we are finding the range of a function, range means we shall find interval of y. Interval of y such that x is defined. Now, you may think that what is the meaning of this defined? Defined means, suppose we are considering a root function fx. Suppose there is a root function here. What is the meaning of defined? Defined means we shall take only those values of x such that this fx exists. That means this fx will be a real number. That means fx will be a real number provided the value inside the root of r is greater than 0. So that is the property of greater than equal to 0. So this is the property of root function. The property of root function is what? The property of root function is that it will be defined when the value inside the root of r is greater than equal to 0, because root never accepts the negative values. It always takes only 0 and the value which is greater than 0. Okay, similarly, if we consider any logarithmic function, if we consider any log function, suppose there is a log function here, then this log function is defined provided this value is greater than 0 and this value also greater than 0. That means base is also greater than 0. First of all, log never accepts negative value. The base also does not accept negative value, and one added condition is also there for the base. What is that one? That this n, it cannot be equal to 1 also. So there are three conditions for logarithmic function. One is it accepts only positive value. It also does not accept 0. It accepts the base. It should be also greater than 0. And there is an added condition for the base. What is that condition? That the base cannot be equal to 1. Okay. Now, similarly, if we take any inverse trigonometric functions, for any inverse trigonometric functions, for example, if we take sine inverse x, this x always lies from -1 to +1, and this one is valid for cos inverse also. So whenever we shall find the domain and range of a function, we have to know the properties of these types of functions. For root over function, the value inside the root over should be greater than 0. For logarithmic functions, all the three conditions should be valid. And for any inverse trigonometric functions, for example, sine inverse and cos inverse, these x, they must lie from -1 to +1. Okay, so let us solve some questions depending upon these functions. Okay, which also came in the previous years JEE mains and advanced. Okay, so first let us find the domain of a function f of x. Let us take this one x. This question came in the previous years jw x square minus 4 plus log of x minus 5 to base 10. We have to find the domain of this function. So you see, this function, it is the combination of two functions. One is root function and the other is logarithmic function. When a function is the combination of two functions, then we have to find the domain of both the functions separately. We should know what is the domain of this part. We should know what is the domain of this part. So here we shall get one interval, here also we shall get one interval. And when we shall get both the interval, we shall take their intersections, and that will be the domain of the entire function. Okay, so see, just now I told you that every root of a function is defined provided this value is greater than equal to 0. So if we take x square minus 4 greater than equal to 0, then what will be the value of x from here? See, whenever we shall find the domain and range of a functions, we need the concepts of some other chapters also. What are those chapters? Those chapters are inequalities, matrix and determinants, and some portions of quadratic equations. Okay, so here we have to apply the concepts of inequality. Okay, for inequality I am giving you two formula. For example, if x square is less than equal to a square, in that case this x, it always lies from minus a to plus a. And if x square is greater than equal to a, then this x always belongs to minus infinity to minus a union a to infinity. We have to put the close bracket because there is a equal to sign. So these are the two formula. You have to remember it whenever you will solve this type of questions. So let us solve it. So x square minus 4, if we write it, we can write it x square minus 4, x square is greater than equal to 4. That means it can be written as x square is greater than equal to 2 square. So x belongs to, you can apply this formula here, x square is greater than equal to a. So x will belong to minus infinity to minus 2 union 2 to infinity. So this is the domain for the first part, and there is another part. So we have got the domain for the first part. Now we have to find the domain of this part also. After we find the domain of this part, we shall take the intersection of these two intervals, and that will be the domain of the entire function. So here this is a logarithmic function. Since this is a logarithmic function, so I told you what is the condition of a logarithmic function. For a logarithmic function, this value, it must be greater than 0. This value has already satisfied all conditions because it is greater than 0 and it is not equal to 1 also. So we have nothing to do with this number. Just we shall apply the condition here. If it has already satisfied the conditions, then we don't need to apply anything with this part. So we shall apply here. So here this is x minus 5 is greater than 0. That means x is greater than 5. So you see, here we have got two intervals. One interval is this one and the other interval is this one. So let us take the intersection of the two intervals. So for the first case, it is minus 2, it is 2. So x is lying in this part. And this 2 is also there in the interval. This 2 is also there in the interval. And for this one, it is 5 to infinity. That means for this one, this is the interval. So if we observe properly, we can see that this is the common part. This portion is the common portion of both the interval. That means 5 to infinity. So x, if we consider both the function 5 to infinity, so x belongs to 5 to infinity, and this is the domain of the entire function. So the required domain is 5 to infinity. So let us take some more examples where we have to find the domain of the functions. Let us consider a function fx such that fx is equal to x square minus 4 and log of x cube minus x to base 10. See here again we have got two functions. That means this single function is divided into two parts. So we have to find the domain in this case also, and we have to find the domain in this case also. So let us find the domain of this part. It's a very simple part. What is the domain of this function? Same thing. X square minus 4, it should be greater than equal to 0. Okay, so let us do one thing. Let us make it, because already we have done this types of sums in the previous part. So let us write it 4 minus x square. Okay, so if since this is a reciprocal function, so this cannot be equal to 0, because if it is 0, it will be undefined. So let us take this 4 minus x square not equal to 0. So 4 minus x square is not equal to 0 here. So what are the values of x minus x square? So the possible values of x are x equal to plus, x is not equal to plus minus 2. Okay, so if we find the domain of this function, again same thing will come. This part is greater than 0, so we shall take x cube minus x greater than equal to 0. Now you see, now we have to apply a new technique here to find the domain of this function. What is the new technique here? Here I am going to apply wavy curve method. And what is wavy curve method? You see, before we apply wavy curve method, first of all, we have to see what is which part has the highest power. This part, it has the highest power. And the rule of wavy curve method is that we have to make positive sign before the highest power. So it is already positive. So we don't need to do anything here. Okay. So let us make it positive. It is already positive. After that, we have to factorize this part and we shall find the value of x. So if we factorize this part, it will be x, if you take x common, it is x square minus 1. This is greater than equal to 0. Then it is x plus 1, x minus 1, greater than equal to 0. Now we have to consider each part to be 0 according to the wavy curve method. So we can see that this value is 0, this is minus 1, and this is 1. After that, we shall plot these numbers on the number line. Then it is minus 1, this is 0, and this is 1. And this is minus infinity, and this is plus infinity. Now you see, according to the wavy curve method, from the end, always we shall put alternative positive negative sign. So it will be positive, then it is negative, then it is positive, then it is negative. And after that, there is again technique. What is that technique? We have to see the last line. Here the last line is greater than equal to 0. If it is greater than equal to 0, then we shall take only the positive part. And if it is less than 0, we shall take only the negative part. Since this value is greater than 0, so we shall take positive part. And what is the name of the positive part? Minus 1 to 0 and 1 to infinity. So here x belongs to minus 1 to 0 union 1 to infinity. There will be no equal to sign because it is log function, and log function does not accept any value which is equal to 0. So here the value is minus 1 to 0 union 1 to infinity. And according to this first interval, x cannot be equal to plus minus 2 also. So you see, now we will see whether this minus 2 and plus 2 is lying in this interval or not. If minus 2 and plus 2 is lying in this interval, we have to cancel that part. Okay, so if we take minus 1 to 0 and 1 to infinity, then minus 1, minus 2, it is not lying in this interval. But plus 2, it is lying in this interval. So we have to cancel 2 from here. So finally what we have got? Finally we have got that x belongs to minus 1 to 0 union 1 to infinity and minus 2. So this is the domain of the entire function. So generally in JEE mains and advanced, these types of questions are coming where there are multiple functions. So if there are multiple functions, the same technique we have to apply. Just we shall apply the conditions of the functions and we shall find the domain in each case. After that, finally we shall take the common interval of all the functions. Okay, thank you.